uncertainty, a feeling that we and many before us have felt when dealing with the laws that govern our universe, more specifically with the matter of quantum mechanics. This feeling was encapsulated by the famous scientist Werner Heisenberg in a principle by the name of Heisenberg's uncertainty principle. This principle, as we all know, is defined as the inability to measure the position and velocity of an object at the same time. But what does this really mean? Well, you must see this principle in action to understand it. Here we have a laser. It's shown through a slit that can be adjusted to be larger or smaller. Now, as you begin to tighten the slit, you can see that the dot becomes thinner and thinner. This is expected. But if the slit gets even smaller, an interesting phenomena occurs that you wouldn't anticipate. You can see the once narrow beam of light begins to widen out. As the slit gets smaller, the beam of light gets wider. Now, why is this happening? Well, that's where Heisenberg's uncertainty principle comes into play. We must begin with the equation that governs this principle, which is known as delta x multiplied by delta p is greater than or equal to Planck's constant divided by 4 multiplied by pi. Now, you must be wondering, what do all these variables even mean and what significance do they hold? Well, x is the position of a particle and p is the momentum it holds. So with this taken into account, we can say that delta x is the uncertainty in the position and that delta p is the uncertainty in the momentum. Now, with these two variables are multiplied, they must be greater than or equal to Planck's constant divided by 4 pi. How does this relate to the experiment I just showed you, you may be thinking? Well, as we made the slit smaller, we were simultaneously decreasing delta x for those photons. In other words, we were making the photons more precise. But looking back at the equation, we can tell that if delta x keeps decreasing, we're going to break this relationship of uncertainty. Why? Well, because of the symbol here. This side of the equation must be greater than or equal to the other. So in order to counteract this, delta p, the uncertainty and momentum in the x direction, aka horizontal direction, must increase. This means that the photons go to the left and right now instead of going straight. The photons don't do this consciously, of course. It happens as the uncertainty cannot decrease too much due to the laws of physics in our universe. So to sum this up, the smaller you make the slit, aka decrease the uncertainty in position, the more you will increase the uncertainty in momentum. Hence why, as the photons go left and right, the beam will get wider.